Good afternoon, everybody. It's 5 o'clock on Tuesday, which means it's time for math. My name is Jeremy Jasper, and I'm with KathleenJasper.com. And just like we do every Tuesday from 5 to 6 p.m., I'm going to do 10 problems of math for your teacher certification exams. So we are right in the dead of summer. It's the second week of July. Everybody's you're either in just summer mode, lounging mode. Not many people are interested in their certification exams, but now is the time to really get focused and get them out of the way, because next thing you know, in the next 3 to 4 weeks, you're going to start having those notices for preschool week, and you're getting your schedules and you're finding out which students are in your classes and all that good stuff, and having to get your room ready. So the best time to get all your certification exams out of the way is right now, because you have the time to take the tests, to study, to get everything you need to get done before the school year starts. And the next thing you know, it's Christmas break and you're like, what in the world happened? So we're going to go ahead and get right to it. If you're new to us, thanks for joining, but we do 10 problems every week. And if you look, whether you're on Facebook or you're on YouTube, there's a link below. You can get the 10 problems that I'm doing. All 10 problems are done on a separate sheet of paper. That's because I give you that scratch area underneath, because remember, you are taking these exams on a computer, and therefore the only thing you can write on is a blank piece of paper. So make sure that you are practicing looking at a problem and then only writing on blank space, because you can't write underneath the problem like you would in a workbook or printed out paper. And then the second thing is, like I say all the time, make sure you've got the right calculator. All these tests have calculators except for a select few, but for the most part, you will see what calculator you are allowed to use if you look up your test specs on whatever test that you will be taking. All right, so now let's go ahead and just get this thing underway. What do you say? Okay, there we go. All right, our first problem came to me from somebody who's taking probably the high school or something to that equivalent. So this one might not be right up your alley, but don't fear, because I'm going to show you the way that I solve it. I'm just going to, when it says which of the following functions is odd, that may mean absolutely nothing to you, but I'm going to show you how to figure out whether or not something is odd or even. And then figuring it out will be beneficial to you, because it's just using algebra. And that happens with a lot of these problems. Algebra is universal. So it's going to be used in every single certification exam that you see. So you have to make sure that you have a good understanding of just the basics of algebra so that you can get through most of this. When it says which of the following functions is odd, it's asking you about the function itself. So for the sake of this question, and we're just going to presume that we know what we know, I'm going to tell you what odd and even are. What happens is you have this right here. As soon as I can get the pen. You see how this is a function of x, and that's a positive x. The way to determine whether in this case it's odd is if you substitute. So you substitute a negative x, just like that. So anything that has x in it, we now put a negative x. So that would be here and here. Then we go ahead and we see whether or not it's and this is, so same function. Give me a few problems to get my handwriting down, but the writing isn't the important part. It's usually the numbers I do, so that's okay. So if it's the same function, so that means if I substitute a negative x into any of these functions and I get the same function, then this is an even function, okay? honestly, don't worry about why, because they're going to just ask you in an equation form instead of giving you a graph, because the graph would be easier. But in this case, it's giving you the equation, find out whether or not it's even or odd. If it is the opposite function, and that means all signs are different, it's the complete opposite, then it's an odd. And that's what we're looking for. We're looking for, when we input a negative x into these equations, will we get the exact opposite, the complete opposite? And if we do, then bingo, that's our answer. And then if neither of these happen, then nothing, no match. No match meaning not odd, not even. So this is a possibility as well. If nothing happens, if let's say one of them is even and one of them is odd and it doesn't work out to where it's either the same or the opposite, then it's neither. And obviously we're looking for odds. So that's what the answer is going to be. Okay. So we are looking for the complete opposite function in order for it to be odd. So now that we know that, let's go ahead and put it through. And so now this is good for everybody else. This is what you should practice. So you may not get a question like this. You may be on elementary education and you'll never see a question like this. But what I will tell you is, so we are going to sub negative x for x. So now go ahead and do that just so you can practice. The first one, and we're just going to go right down the line, 2, and then this is now a negative x to the third power plus 8 negative x. Now you see how I'm putting these negative x's in parentheses. I suggest that you do that anytime you're substituting a value, use parentheses, because especially when there's a negative, if they're not in parentheses, you may, I don't know, sometimes you just might do that. Like that says 8 minus x. Just, I don't know, something silly can happen. Something silly can always happen on these tests that you don't expect. And it's just, it gets crazy. Your mind's not right. You're stressed out. You're anxious. So that's why go ahead and protect those x's. Now, if I go ahead and I do 2 and then negative x to the third power, I'm going to, go ahead and extrapolate it out, which means that's x negative 3 times. And then this one is going to be 8 negative x. I want you to see this right here, okay? Because basically we're just multiplying negatives. We have negative times a negative is a positive, and then a positive times a negative is a negative. So negative x to the third power is going to be negative 2x, okay? And then we have plus negative x, so that's going to give us minus 8x. As soon as I see that, I am going to go ahead and look at my original. So I'll go ahead and write it right here. So minus 2x minus 8x is going to give me the complete opposite. And this is what I mean by the opposite. See how this is a positive 2x cubed? Then that means minus 2x would be an odd. See how this is positive 8x? Negative 8x would be odd. Therefore, that fits the situation that I'm looking for. And this is going to be an odd function. That's what I'm looking for, odd function. And so A is going to be the answer. Okay, so now let me just go through the rest of them just so I can show you. And same thing applies. Again, I want you to focus on the exponents as well. This one is going to be negative x to the fifth power plus 3 negative x to the third power plus 7. And remember, we're looking for the odd function. I know I already found it, but just so you can recognize the patterns here. See how we had to the third power here and it was negative, and to the fifth power here and we had a negative. If you have an odd power, and you are multiplying with the negative sign. Again, if I really need to, if I did it 5 times, okay, negative to positive, negative to positive, negative. Odd powers with a negative sign are always going to be negative, okay? So if you can remember that, that helps a problem like this, or if you get an algebra problem like this, go much quicker. Yeah, I saw that person retracted their message. Nice job, buddy. So it's all going to be negative. So I know that's going to be negative x to the 5th power. And then the same thing here. See the 3? 3 is odd. It's not going to do anything with that negative. It's going to go negative, positive, negative. So that gives me negative 3x to the 3rd power. And then I have plus 7. So now remember what we're looking for. We're looking for the opposite. Is this the opposite? If I write this next to here, I got negative x to the 5th power minus 3x to the 3rd power, and then plus 7. It has to be the complete opposite in order to be odd. I've got positive and negative. I got positive and negative, but I've got 2 positive 7s. So it's not the opposite and it's not the same. So it falls under the neither category. Okay. And so that's what we would do when we're looking for something like this. Okay. So that's how you figure out if a function is odd or if it's even. And let me just go real quick. And again, use this to just practice. Okay. So ask what exam is this for? This is exam would be for like a high school math or an upper level math. So they would ask you which of the following functions is odd or even. Okay. But what I'm telling you to do in order to find whether a function is odd or even, because remember, if you're looking for practice, then you need to go ahead and find the value in any problem that you can, right? And so substituting in a variable, which in this case would be the negative x for the x, that shows you how to use that, that skill. And so just to finish it off, here's something where I have 4 and then negative x squared plus 8 and then negative x and then plus 4. I've got an even numbered power here and I'm dealing with a negative sign. So I know that's going to be positive, whether that's 2, 4, 6, 8, 10, all the way up. It's always going to be a positive when we're using a negative number. So that's going to be 4x and then 8 and a negative x is going to be minus 8x. And then we have plus 4. Anytime we have one of these hanging on here, it's not going to be affected by that negative x. So therefore, it's going to be very tough to keep it or to make it different, which would be odd. But if it's the same, you know, you got to be careful with that as well. Either way, again, I don't have the opposite because I've got a positive 4x here and then plus 8x is opposite. And then 4 is the same. So that's a neither. So that doesn't work out. I think the last one is the same. I don't know. But again, just reinforcing if it's negative x and it's going 9 times, and this is 13, and it's going 8 times, well, this one is going to be odd and it's negative. And then this one's going to be even, just like that. Okay. And again, that never changed, doesn't change. Bang, bang, bang. A is the correct answer. Okay, Green Education Center. All right, next problem. So that takes care of that one. I just wanted to put that on there because somebody requested that. And you can request a problem anytime that you like. I will tell you at the end. So a lot of these problems do come from you because that's why I'm doing it. I'm here to help you all out with the problems that you're coming across. So this one right here says, Ms. Jefferson read an article to her class describing a survey of students who were asked to choose their favorite color among the colors yellow, blue, red, green, or green, red. The graph above shows the results of the survey. Ms. Jefferson tells the class that the survey results are representative of all students, and she asked the class to predict how many of the 850 students in their school would choose either yellow or green. Which of the following is the best estimate? So I have told you many times when we do these problems that estimating is going to be your best weapon, because a lot of the times for these problems that they make, they take that into account. Excuse me. And so being able to estimate takes away doing a lot of work and also getting frustrated that you're not getting the exact answer. There are a lot of people that will get really stressed out if they can't get an exact answer. So in this case, we need the estimate, and they give us that there's 850 students. But if you look at this graph here, I have absolutely no way of telling what numbers correlate to which color. With the 850, I got to go either yellow or green. That means yellow and green. Okay. So how are we going to figure this out? And the best way to figure this out is just through basic estimation. If I see this as red and I just draw a line straight down, that's a terrible line because if I were to do that, red looks like, if we estimate it, what if I just drew that half? If I gave you half of a circle, that's 50% of that circle, right? And so now what we're going to do is, if I have 850 students total, we can start breaking these things down. Now it's a matter of how you want to do it. If I broke that down into 50%, that leaves me with the yellow, the blue, and the green, which represent about 50% of the population, okay? If I take this blue out, now the way that the blue is, it's kind of funky because it takes up a large chunk. And what I see here is that blue takes up about half of the half that I made up. So I've got half of a half. So half of a half is equal to a quarter, right? So I can break this down as 50%, right? And then I can roughly say that that's 25%, which leaves me with yellow and green. So 50, 25, and 25 give me 100%. So the way that I want to do this is, if I know that the yellow and green are roughly 25%, let's take that as an estimate, right? Because if I do 100% is everything. Take away 50 for the red, take away 25 for the blue, and I'm left with 25%. If I were to take 25%, well, let's do this first because some of you take 25% and make it a decimal, okay? How do we do that? Put the point here and go 1, 2 to the left, and you now have 0.25. Or percent, just like it sounds, percent per 100, 25 over 100 gives you 0.25. You can always do it in your calculator. You'll always get the right decimal and it'll work out, okay? So let me clean this up real quick. Okay, so I'm estimating that 850 times 0.25 is going to give me so I have 212.5. Looking at the answer choices, okay? So I know right away that 20 and that 25 are way too small, but now it's giving me 150 and 250. And I got 212.5. Now remember, I was pretty generous with this red, right? So I said that this red is 50%. It's not really 50%, right? Because you see that little sliver right here? That means it's less than 50%. If it's less than 50%, that means that this number has to go up because it has to compensate for that little sliver that I gave to the red, right? Take from the red and give to the others. That's going to compensate. That right there shows that this 212, because I went low, right? I cut this in half already. I went low, so that means I have to give more. Out of these two, again, best estimate, they are not asking, you cannot prove that the right answer is 250, like for a fact, right? Because they're not giving you the necessary information, the percentages breakdown in the pie chart, and all that kind of stuff. So because you estimate, you got an idea which one is closest to the answer. 250 is your answer, and then you move on. Okay. Don't get frustrated with, oh, I don't have the right percentage breakdown, or I don't have angle measures, or I don't have any of that stuff. Just go ahead and look at it, kind of feel it out, and then give yourself the best option. Okay. All right. Next one here. I always like to add this. I haven't done one of these in a while. The height of each student at Jefferson Middle was measured and recorded. Joseph was told his height was at the 60th percentile of heights of students. Which of the following must be true? So when they assess this, and they do assess this on a lot of exams, the 60th percentile does not mean 60%, right? You have per, you guys are making me write again. You get percentile, percent, and then percentage. Okay, there's three of them. We want to deal with percentile. Okay, so the percentile means you are at, or, well, it's really at or below. And it's easy to figure out when we say, as we look at the answer choices, the heights of 4 students are greater than that of Joseph's. You can't figure that out because you don't know how many students there are and you don't know their heights. So that's something that you cannot figure out. B says Joseph's height is 60 inches. Maybe it is 60 inches, but I don't know that. And that has absolutely no bearing on his percentile rank, because what if everybody is 60 inches? Or what if nobody is 60 inches? You can't tell, not enough information. C says the heights of at least 60% of the students are less than or equal to Joseph's height. That is the definition of percentile right there. It's at or below. That's it. You reach the 60th percentile, you were at 60% of or below everybody in your sample size. In this case, it's his class, it's its school, whatever. So that's why things change when you're doing percentiles in your school. One kid could be in a high percentile in his class, but then drop down a percentile based off of the school, and then go even further if it's based off of the district. So that's how those types of things are done when we're dealing with percentiles. So C is going to be the right answer here. And then D says if the height of the tall students is 70 inches, then Joseph's height is 0.6 times that. Remember, percentile has absolutely nothing to do with percentage. Okay, so don't get that mixed up. All right. Next problem we've got in 2016, Mr. Chupin, whatever. And that's another thing. And they do this a lot on tests, is they give you funky names and you spend a second or two trying to pronounce the name. If it's a goofy name, whatever. And I tell my daughter this all the time, and all younger kids that are taking exams, just use the first letter. So I've got Mr. S paid an annual property tax of $1,500. In 2017, he paid an annual property tax of $1,650. What was the percent increase of Mr. S's property tax from 16 to 17. So we get into percentile change or percent change or percent increase or percent decrease. And just make sure that I'm going to show you the formula. So it's always new minus original divided by original. But here's the other thing. It doesn't matter if you put the ones on the top first or second, honestly, in my opinion, just for testing purposes, because you'll still get the right answer. This is the most important. You have to know that in your denominator that you have to have the original price that was given, okay? So with percent change, and here's what I mean by that. Our new price, that means in 16, he paid 1,500, in 17, he paid 1,650. So I've got 1,650 minus 1,500 divided by 1,500. Well, that's just a change of 150 over 1,500, which is 0.1 or 0.10, making that into a percentage, 10%. So C is the correct answer. Now, see how this was a positive number? This was a positive 150. That's how you can tell that you did it right, technically, because it said it was going to be a percent increase. Okay. What if it was different? And here's why I'm telling you, it doesn't matter what you put on the top. Okay. Let's say, for argument's sake, that you didn't have this new minus original over original, and you just started with the number that he paid first, because that was in the problem first, and then the number that he paid second, because that was in the problem second. Well, what do you get? You get negative 150 over 1,500, which gives us negative 0.10. Now, I have all the confidence in the world that if you did it this way and you went ahead and you, and you went ahead and you've got this negative 150, that you would get the negative 10%. You look at your answer choices, you would see that there's a 10% there. Okay. So if you flip the top numbers, all right, then you're okay. Whether you get negative or positive, because they're never going to say, oh, you got a negative percent. It'll always say either percent increase or percent decrease. And so that's why it's okay to flip around the top numbers, but make sure that you get that bottom number right. Okay. Yeah, see, that bottom number is the most important number. Don't get that wrong, just like the commenter did. That's not good. You start doing these things too quickly, and that's how you get wrong answers. All right, problem 5. I picked this one out specifically because you're going to see a lot of word problems like this. Who's Gina? Do you use new original for percent increase? Yeah, that is the way. Yeah, Gina, that question that you're asking. So she's asking, do you use new minus original for percent increase, decrease? Yeah. So let me go back real quick. Let's just pretend what I just did, how I did the 1,500 minus the 1,650. What if I said our annual property tax was 1,650 and then it went to 1,500? Obviously that went down, right? So instead of percent increase, this would say decrease. You know, that says decrease because I'm just answering your question. And you will notice I get the negative 150. That negative 150 signifies that I am in a percent decrease problem, but they will never have negative 10%. You will just say, hey, it decreased 10%. So you are correct. Make sure you use that for all of these percent increase or decrease problems. All right. So now for this one, This is all words and there's no math involved. So this is what we used to do all the time in our seminars, is teaching people how to pick out good words. And if you have any of our guidebooks, you'll know that we have pages dedicated just for good words. You see a problem like this: math teacher assigns students 6th grade class keep mathematics diary. Every day the students are asked to record when and how they use math in their lives. At the end of the week, the student writes a short report, use math, teacher reviews diaries. Which of the following is teacher demonstrating with this activity? And you get these big answer choices. So we go through A, an understanding of a variety of questioning strategies to encourage mathematical discourse and to help students analyze, evaluate, and communicate their mathematical thinking. Okay, that is a fantastic answer. All right, and I'm just gonna go through it, and honestly, it's very superficial. Look at answer choice A. Answer choice A is one of the longest answer choices in the available. So right away, I'm gonna gravitate towards that one. But I need to go through all of them because I just have to make sure. B says an understanding, use inductive reasoning to make conjectures and deductive methods to evaluate the validity of conjectures. All right, I didn't see anything about conjectures in this problem, so I'm going to knock that one out right away. The second one says an understanding of the purpose, characteristics, and uses of summative assessments. All right, are we using a summative assessment when we are doing each week, at the end of each week, a short report or a review in their diary? Okay, that's more of not summative, but informal assessments. Okay, so that's gone right there. Then the second, or the last one, an understanding how technological tools and manipulatives can be used appropriately to assist students in developing, comprehending, and applying mathematical concepts. All right, what do you notice about this one? In this one, it's just as long as A, so I'm going to consider it. And I'm only going to consider it just because I want to break these down for you. We want to look for these good words. So I'm sure a lot of you are familiar with Bloom's. So Bloom's taxonomy. We just call them Bloom's words. So these are all of our critical thinking words. In these first, so I like understanding, and then our Bloom's words are analyze, evaluate, and communicate. Those are high level words. Those are good critical thinking words. If you see those in answer choices, you want to gravitate towards those answer choices. So that's why I like A. And then if you look at D, you got the same thing. Students in developing, comprehending, and applying. Those are also great words. You also have technology. All these words, like if you use our guides, we show you, this is how you pinpoint the right answer choices for these types of questions. I could look at these answer choices and I can almost tell you what the answer is. The problem is A and D are very similar. So we have to refer to what they're talking about in the actual problem. Okay. Because it seems like these test people are kind of, they're getting onto the game where a lot of people are starting to attack these problems like this. So, and a lot of times when you take these tests, you just look at the answer choices first. I don't want to choose D because I'm not using anything technological. This is the one that makes it the wrong answer, because no technology and no manipulatives, because we are specifically doing the math diary and we're focusing on what we're doing at the end of the week. And so this is why we have a variety of questioning strategies to encourage mathematical discourse. Okay, what did I understand? What do I know? What do I want to learn? All of that kind of stuff. And so that's why A is the correct answer. So really work on, even though these are math questions, because it refers to the math test and doing things in math, we still have to understand how to do this kind of stuff. Okay, so I wanted to throw one of these questions on there because it's good practice. All right, back to more numbers and stuff. Question 6 has us with two rectangles. We got two rectangles, A and B, and they are similar. Rectangle A has a length of 100 centimeters and a width of 50. If the area of rectangle B is 200 square centimeters, what is its perimeter? Okay. How are we going to figure this out? Number one, this word similar is very important. What does similar mean? Similar means that rectangle A and rectangle B, again, I don't know what they are, but they are proportional to each other. Similar means proportional. It means that A is so many times bigger than B, or A is so many times smaller than B. If they give me that A is 100 by 50, so I've got 100 by 50, okay, and that gives me length and width. So that's length and width. Then that means if I take, and let's just do this, let's do length over width. If I do length over width, I have 100 over 50, which is the same as 2 over 1. So rectangle B has to be in the same proportion. It means that the length has to be twice what the width is. Does that make sense? If the length is 100, that's twice as much as the width, which is 50. That's why I broke it down into this fraction or this ratio here. And so it's 2 over 1. Now, how am I going to get my dimensions for B, because I have to find perimeter? Well, if the area is 200, so area equals 200, yikes. How is that information going to help you? And I will show you. So let me make some room. So I know that this is in a 2-to-1 ratio. And I have to do the same thing for this. How do I find area? Area equals length times width, right? So then if I just factor out 200, won't I end up finding all my factors of 200, right? Because it has to be those two numbers multiplied together, and then they have to equal 200. So I know a lot of you might already be able to do this in your head, but if I just break it down for you, you'll see, 1 and 200. Obviously, that's not going to work out because it's, that's not in a 2-to-1 ratio. And then I go 2 and 100. And again, I'm just showing you all of these so you get the idea. 4 and 50, 5 and 40. I wish I would have made this higher. 5 and 40, then 8 and 25. And then the next one, sorry, I had to go over here. The next one is 10. I'm sorry. Oh, I did these backwards. I'm sorry. Hold on. I was looking at my sheet and I did. Hold on. Stand by. That'll give me more room. Hold on. I got to find 200. And I know my length has to be twice my width. So length of 200, obviously that's not going to work out because that's 201. Then I can do 102, no go. Then I can do 50 and 4, or I can do 40 and 5. Then I've got 25 and 8, and then I get to 20 and 10. And when I see this right here, 20 and 10, 20 times 10 gives me 200. And then if I do 20 over 10, that gives me 2 over 1. That matches because it means they're similar. They're in the same ratio. Length over width is 2 over 1. And then 20 times 10 gives me 200. Is that my answer? No. That's why you got to be careful with problems like this, because there's like 3 steps involved. First, you got to figure out what the ratio is. Then you've got to figure out what your dimensions are for your area. And then now you have to get to what the actual question is. What's the actual question? It says, find me the perimeter, which is right here. So how do I find perimeter? Well, you just take the dimensions. It's the addition of all four sides. If you know that they're 20 and 10, you have two sides that are 20 and two sides that are 10. I don't know why I did it that way. 40 and 20 give me 60. 60 is your answer. Okay. All right. Let me just double check. Everything's looking good. Glad everybody's participating on YouTube. Let me make sure our friends on the FB are doing okay. Give me 1 second. Any comment? Nope. Okay. Likes good, like that. All right. All right, let's go ahead. Let's finish this bad boy up strong. Okay. Number 7. Number 7 says a car that is advertised for $28,900 is sold after an 8% discount. If the commission rate is 0.75% of the sale price, how much money will the salesperson earn? Okay, so dealing with percentages. All right. So let me show you how I would do this problem the fast way, and then I'll show you the other way just so that you get an idea of why there are two different ways of doing this. Again, like I always say, I encourage you to do it the way that you are most comfortable. Okay. Do not change your habits or anything, just because you saw this session and your test is tomorrow, unless you're really confident about it. But you have to be careful, changing everything up, or, especially if I show you something and you really like the way that I did it. Well, then that means you need to practice it a few times instead of just saying, oh, I'll remember it once and then I'll go into the test. So now what we've got to do is I've got this 28,900 and I got an 8% discount and my commission is 0.75. This is really why I chose this program, because of the 0.75%, because that's going to throw people off as well. So if there were an 8% discount, I always do this in my head first, whether it's a discount or whether it is an addition to what, it's like a tax or something like that. 28,900 represents 100% of your price. And that goes with anything. Anytime you're selling something or whatever the price is, that is equivalent to 100%. If I have an 8% discount, I no longer have 100%. I take 8% away. If I'm taking 8% away, that means you're paying 92% of that price. So now with my 28,900, I'm going to pay 0.92 or 92%. We already went over how to find a decimal to a percent and vice versa. So that's going to give me my new price that I paid for this. And then my guy gets a 0.75 commission. Here's where your calculator may come into play. If I have 0.75, a lot of you are not used to seeing decimal percentages. This is 0.75%, right? It's 0.75%. So we're so used to taking that decimal from here and moving it to, well, that's not where the decimal is now. Okay. We only do that when there's whole numbers. The decimal is here. So I've got to go 1, 2. Well, what happens when I go 1, 2? It's almost like I went nowhere because there's no space. Remember, anything that is empty space gets filled in with a 0. So 0.75% is equivalent to 0.0075. These are the ones that I recommend pulling out your calculator and doing, like I've showed you before. If it's 0.75%, percent means for every 100. When you divide it, your calculator is going to spit out the correct decimal form of your number. Once we know that, All right. Now, again, I'm explaining all of this to you so you can see the process, but this is going to go super quick. My price out of 100%, I take 8 away. I'm only paying 92. And then my commission is 0.0075. Now all I do is just run it through the calculator and you will see that it equals 199.41. And that is my guy's commission. Okay. So that is a nice and easy way of doing this. Now, here is the way that most people do it. And I want to, again, do it if you want to do it. It's great. It's going to work. But I will tell you, it takes time. And your number one goal on these tests is to save as much time as possible. Write down as less as possible, because time is of the essence. And a lot of you that aren't passing your tests, you're running out of time. That's what I find the most happening. Somebody's going to do this. All right, I sold my car. Oh, wait, there's an 8% discount. So let's go ahead and let's take our 8% discount. So that's 0.08. So as soon as I do that, I know that I'm down 23.12. So then what do I have to do with that 23.12? Well, I take 28,900 minus 23.12, and then I end up with 26,588. And then I say, okay, that is my new price with my 8% discount. Then I have to go ahead and take this 26,588 and then multiply it by 0.0075. And then I end up with my 199.41. Again, when I did it, I eliminated these two steps here, but ultimately you're going to get the same answer. It's going to be the right answer. Do it the way that you feel most comfortable. Okay. Learning how to knock this out instead of having the 0.08, right? Instead of doing it in your head, take the 100 minus 8. That'll be very effective, because there are multiple problems on these tests where they give you percentages, whether it's a discount or a fee or something. And so I just want to make it a little easier for you. Okay. I love these problems because these problems tend to confuse a lot of people. And so I'm showing this to you now so that you do not get confused. Okay, simple enough. We have a hiker climbing uphill at a steady pace. He rests at a scenic spot for a while, continues at a slower pace to the top of the hill. The hiker stops for lunch at the top, decides to run down to the base of the hill. Which of the following graphs best expresses the hiker's speed as a function of time? Oh boy. If you get a problem like this, be mindful of what the narrative is, number one, and also be mindful of your X and your Y axis. All right, because that's going to be very important. We're going to eliminate these right away because these are not continuous graphs. All right. They've got these little open ends. That means it goes from 0 to here and it doesn't reach that point. And then it starts again at here to here. And then it's just a whole mess. So they're doing that to confuse you. And sometimes they do a great job of doing that. And a lot of the times, if you get frustrated, you go with the most difficult looking answer choice that there is because you're unsure of yourself. And I get it. It happens to everybody. And so that's why I'm trying to show you these. All right. If we're going up a hill, it says hiker climbs a hill at a steady pace and then he rests. The problem with these is you want to visualize what this hiker is doing. And if I go up a hill, doesn't this look like a hill? And then me stopping and then me going up a hill again and then stopping and then going down a hill again. Okay. That looks like the mountain that we are climbing. And that is not the case. Okay. So let's break it down real quick so we can see. If my hiker climbs up a hill at a steady pace, all right, here is me. This is time. So time never stops. That's the beauty of time. Time never stops. So we're good where we have all of these lines going from left to right continuously. But what this little arrow shows is his speed is increasing. This is like 0 miles an hour. And let's call this 10 miles an hour. Now, 10 miles an hour, that's kind of ridiculous, right? So he went from 0 to 10. So this is an increase in speed, super quick. Uh-oh. All right. But this said steady pace. Let's call this 0. Let's call this 10. Would you agree that over time, this flat line right here, and again, this is why we have these types of questions, because this is confusing. Your mind is saying, well, if I'm going, then my graph should be going up because that represents, you know, more speed or more time. This is a continuous pace. I'm going at 10 miles an hour. Let's call this, I don't even say, let's call this, you know, 1, 2, 3, 4. All right. We can put whatever we want on here, but just understand over a period of time, this line is a consistent speed. This line over here on A is not a consistent speed or a steady speed, is it? This is an increasing speed. This is increasing from 0 to, I call it 10, but it can be whatever. But I just want you to understand that. Based off of that right there, I already know that C is the correct answer. But let's just follow it through just again, so you understand how to read these graphs. And then he rests. Well, if we are resting, are we slowing down to a stop? That's what this represents here. This is me slowing down. And then ultimately at 0 speed, I'm done. I have been resting over time. And so again, that checks out. Then continues at a slower pace to the top of the hill. So our first pace was here. Again, obviously this is less than this one. So that's our slow pace. And then we stop for lunch. No speed here. That means we stop. And then running down the hill. So see how we go quickly straight up. That means we accelerated at a quicker rate instead of our steady speed, which was at the beginning. So it's important to know how to read these graphs over time, because a lot of people will make the mistake of climbing up a hill has the same representation in a graph as a picture of a hill. And that's not the case, right? We are not walking up here and then walking down the hill. It's done on this one right here. So please don't make that mistake. Okay. Problem 9. Which of the following equation of of a line perpendicular to the line 4x minus 9y equals 12? A lot of questions about this. I'm going to solve this for you super quick. I always solve these in 3 steps. Okay. So first off, we need to know what is perpendicular line. So perpendicular deals with slope, super quick, super quick. Y equals mx plus b. Put it in this form right here. That's going to tell us our slope. Okay. Guess what? When we're dealing with slopes, lines, perpendicular, parallel, bye-bye. I don't need that number. I am only looking for this right here. Okay. So that means solve whatever equation they're giving you for y, and then only focus on what is attached to the x. So with that being said, the first step is to rewrite it, because again, you're not going to be able to do anything to it because you're on scratch paper and you're looking at a computer screen. I want to go ahead and get the y by itself. So that means I take this x over to here. So move the x. So I'm left with negative 9y equals negative 4x. And then guess what? That is irrelevant. That is irrelevant for this problem because it is not necessary to know what the y-intercept is when you're looking for a perpendicular line. You're only focusing on the slope. So I solve for y. Okay, well, I move I get the y by itself by moving the x on the other side and getting rid of whatever whole number is there. Then the last step is divide by whatever is hanging on to the y. So divide by -9. That's gone. This gives me -4/9. Negative and a negative make a positive, which means I have +4/9 x. X doesn't really matter here. Okay. Now, what does perpendicular mean? Perpendicular means, let me write it up here. Perpendicular means opposite reciprocal. Now, I say opposite. A lot of people say negative reciprocal, and that's bad language because you don't always make it negative. It's the opposite sign and then the reciprocal. So do we agree that we have 4/9 as the slope to this function here? Yes. So we take that. I'm just going to erase this over here. If I have 4/9, then my opposite reciprocal is going to be, this is positive, I make it negative, and then reciprocal means to flip the slope, flip the fraction. 9/4. This right here is now going to be the perpendicular line to that function that they gave us in the beginning of the problem. Again, y-intercept does not matter in this case. It's all about the slope. So with a -9/4, the only one, right? 4/9, 4/9, positive, negative, D is the correct answer. So you can solve those in 3 steps. Get your function, move the x over, get rid of that number, and then divide by whatever's on the y. That gets your slope. And then from there, it's either parallel or perpendicular. Parallel means same slope. So if I had 4/9, so answer choice B, that would have been a parallel line. This one is parallel because it's the same slope. Okay. All right. And the last one. Milkshakes come in chocolate, vanilla, and strawberry. 2 people ordered milkshakes, but their orders were lost. If each person is given a randomly chosen flavor, what is the probability that they will both get the flavor they ordered? All right, this one seems simple enough. I chose this one just because I feel like you may get it confused because when we get problems like this with 3 flavors, they usually ask for the combination. So with 3 flavors, how would you find the different combinations, right? And it's just, it's 3 different flavors. Because usually they do flavors with types of toppings and then different types of cones, but that's not what this problem is. So it's giving me 2 people ordered, I lost their order. What is the probability that I just serve them 2 things and I get it right? There are 3 possibilities. So in a probability problem, we always want what it is over the possible choices, okay? So the first person will have 1 out of 3. I have a 1 out of 3 shot of getting it right. Agree? Because there's 3 flavors and I choose one of them and I have a 1 out of 3 shot of getting it right. Then there's another person. Whenever there are multiple choices, so and multiple choice, not as like this answer choice here in a problem, but multiple choices as far as you're rolling die and you're rolling it 2 times in a row or 3 times in a row, or you're picking, you're picking something out of a drawer or a bag or a hat multiple times, then you are multiplying, okay? So I have a 1 out of 3 shot for this one. And then there's another person, right? So I have a 1 out of 3 shot of that one. We are multiplying. Don't forget how to multiply fractions. So I do 1 times 1, which is just 1, and then 3 and 3, which is 9. You have a 1 out of 9 shot of getting these 2 people's orders correct. Okay. So the biggest thing here is I need you to focus on whenever you have multiple probability options, where it's like multiple people, multiple rolls of a dice, multiple flips of a coin. You get the idea that you must multiply those two probabilities together, or the multiple probabilities together. Okay. All right. Made it in the hour. Answer key. Always need to have the answer key just so you got the answers. And if you need to contact me, info at Kathleen with a K, Jasper.com. If you have any questions on what you saw tonight, if you have any problems that you would like me to cover, anything in that regard, then by all means, please let me know. Let me just double check if there's comments anywhere else. Looking good. All right, Green Education Center, you are all about it today. So thanks for joining us. We appreciate that. And that's it. So I know it's slow time of the year, but I am here for you. So if you need anything, hit me up, email. All the stuff gets forwarded to me that's math related. Check out our website, KathleenJasper.com. We have other stuff for praxis and other tests instead of just math, but I am here every Tuesday for you so I can help you out, so I can get you to pass your math certification exams. Okay. All right. It has been a good session. I hope you learned something. Again, enjoy your summer, but if you've got tests you got to take, make sure you're getting them done before the school year starts. Enjoy the next week or two, because that's going to be like your last week of freedom until everything starts rolling in for preschool week. And then you got all that to deal with. So if you need anything, please let me know. But other than that, I hope you have a fantastic week, and I will